Okay, welcome to the Chapter 3 review for Math 980. I had two questions and they were both from section 3.4, so we'll take a look at those. The first one was number 8, where we're given this polynomial and we're asked to factor it. So let's factor it. Now the first thing that we'll note is that it's a third degree polynomial, and therefore we should have 3 factors, right? Now that doesn't guarantee that those 3 factors are unique, right? For example, x minus 1 might divide out once. It could possibly divide out twice, right? But there's a lot of techniques, there's a lot of things that we've covered in this chapter, ways to break this down, ways to be smart about breaking it down, and some of those ways, while they're smart, may not be time-saving. Some of them might be. So we'll talk about all of them, but let's go through. Let's just start. The very first thing is your rational zeros. The rational zeros theorem says that you're going to take your p over q, which is to say p is all of the factors of 2, and then q is all of the factors of 6, and that ratio is all of the possible rational zeros that you'll get, right? So that is to say, it's either a positive or negative. The factors of 2 are just 1 and 2, right? And then my q is all of the factors of 6, and those are 1, 2, 3, and 6. Okay. And so that is to say all of my rational zeros are, we'll write them down, it's all positive or negative, so I'll have plus or minus. I'm going to erase this and put it over here. It's plus or minus 1 divided by 1 is 1. 1 divided by 2, 1 divided by 3, and 1 divided by 6. Right? And then I also might have 2 over 1, which is 2. 2 over 2, but that's 1, and I already have it here, so I'm not going to write it twice. I don't need it twice, I just need to know that it's a possible answer. But I have 2 over 3, so 2/3. And then I have 2 over 6, but that's 1 over 3 reduced, and so I have it already, and that's it. That's my list of possible rational zeros. Okay. I'm going to erase what's over here in black. To start, this is what we have. Now, we can look at Descartes' rule of signs. And Descartes' rule of signs tells us where those zeros might be. Sort of. It tells us positive or negative, and it's all potentials, right? But if I look at the number of sign changes of the function itself, right? So 6 is positive, 11 is positive, 3 is negative, that's a sign change. So there's one sign change, but this -2, that stays negative, so it's not a sign change, there's only one. So there's one sign change in the function itself, and therefore there is one possible positive zero, right? One possible positive number that will give us a 0, right? And we haven't hit complex numbers yet. That's in 3.5. So I don't have to worry about any complex numbers in this potentially, but when you get to a test, of course you do. So I would then say that there's 2 possible negatives, right? But it could also be 0, right? It's always reducible by 2. But 1 is not reducible by 2, and so I guaranteed a positive 0, right? I'm not guaranteed a negative 0, but if I do have 1, I have 2. But I know I have a positive. So I'm going to start there, right? And I'm going to go through synthetic division and try to find that positive 0. So I'll take my, 6, 11, -3, and -2. I'm going to start dividing out my positive numbers, and I would hate to have to try to do synthetic with a fraction, so I'm going to start with my whole numbers. I'm going to start with 1, and divide out a 1 in synthetic, I have to have a negative 1 here. It's always the opposite sign. The 6 drops down. 6 times negative 1 is negative 6. 11 minus 6 is 5. Times negative 1 is negative 5. These guys give me negative 8. Times negative 1 gives me an 8. And negative 2 gives me a 6. If that's not a 0 in that last spot right here, then it didn't work, right? It's not a 0. So 1 is out. Okay? Let's try 2. And if 2 works, great, but if 2 does not work, that means I have to either start on my fractions or do my negatives and see if I'm lucky and find one there, right? But let's try our 2. The 6 again drops down. 6 times negative 2 is negative 12. Negative 12 and 11 is negative 1. Times negative 2 is 2. Negative 3 and 2 is negative 1. Times negative 2 is 2. Oh, look at that. That's our guy. That means that 2 is a 0, and x minus 2 is a factor, right? So let's take a look at what that means. I'm going to erase this word because I'm going to get back up to my function itself. Let me leave this though. Let me move on from here. So this tells me then that I have x minus 2, because 2 is a factor, so I have x minus 2, and this, what's left up here is my remaining second degree polynomial. It always gets reduced by 1 because I've divided out one of these x's. So that is 6x squared minus an x, and then just minus 1. Right? And this I'll take up here, and we're going to move on from there. So let's clear ourselves some space. That means I have x minus 2, 6x squared minus x minus 1. And I would just keep going with this second bit here, except that it's a second degree polynomial. I have a bag full of tricks for this, right? I have the quadratic equation, I have factoring by the AC method, I have completing the square, I have all sorts of stuff, right? Let's just use that AC method. 6 times negative 1 is negative 6. I'm looking for factors that have negative 6. There's not that many of them. But I need to combine to be a negative 1. And so it's got to be 2 and negative 3, right? And so this turns into 6x squared plus 2x minus 3x minus 1. I'm going to group these guys. Remember, if this is a negative, that negative belongs to the 3x. So plop a plus in between those two, but make sure that negative sticks with its term and doesn't go on the outside of the parentheses here. From this first grouping, I can factor out 2x, leaving me with 3x plus 1. Here I can factor out just a minus 1 to leave me with 3x plus 1. And then I have 2x minus 1 left over when I factor out the 3x plus 1. And my answer is not complete because I kind of left one of these guys in the dust. Don't forget it, x minus 2 is still there. And that's my factored form. The answer may not be in this form. It may be 3x plus 1 first. It doesn't matter as long as these three factors are there. The order doesn't matter, but that's my factored form of this function, this polynomial. Okay, let's look at number 10. 10 is the same idea. So let's do it. 3.4, number 10. We have x to the 4th minus 5x to the 3rd plus 6x squared plus 4x minus 8. Okay. I'm going to go through the same process here, right? I should have 4 factors. If there's rational factors, they should be all of the factors of 8 divided by all the factors of, well, how lucky is that? 1, right? So my possible rational zeros are 1, 2, 4, and 8, positive or negatives, right? That's not a big list, there's only 4 of them, right? So I'm just going to dive straight into it. I could use Descartes' rule of signs to figure out how many positive or negatives there are. But again, because that's always a potential, it's a maybe 4, maybe 2, maybe 0 kind of a thing. Or if I got 3, it might be 3, it might be 1. I'm just going to dive into it, okay? So I'm going to start with the small numbers because they're easy. Start with 1. If it doesn't work, go to -1, right? 1, -1, 2, -2, so on. If you can knock out 2 with small numbers, that makes life easy, and you don't have to do a lot of work. So let's do it. 1, -5, 6, 4, -8. Right? Let's just start with 1. I'm going to throw in 1 here. That means I'm trying to divide out a -1, right? So this 1 drops down. 1 times 1 is 1. -5 plus 1 is -4. Times 1 is -4. 6 minus 4 is 2. 1 times 2 is 2. 4 plus 2 is 6. Times 1 is 6, and that gives me -2. All right? So it's not 1. Let's try -1. Well, sorry, it's not -1. Let's put a -1 here to try 1. I know it's confusing. It's, I don't like it either. But here we go. All right. 1 drops down. 1 times -1 is -1. -5 and -1 is -6. -6 times -1 is 6. But that gives me a 12. Times -1 is -12. That is -8. And -8 times -1 is a positive 8. 8 and -8 is a 0, so I have one of them, right? Not only do I have one of them, right? -1 is a 0. Or sorry, 1 is a 0, therefore x minus 1 is a factor. Which is to say x equals 1 is my 0, right? Okay. Alright. That doesn't mean that this -1 isn't going to work again, right? And I can ignore this 0 and do synthetic division again on this smaller reduced polynomial. And I'm going to try -1 again, because if it works again, great, and if it does work again, I'm in the clear because then I have a second degree polynomial, because I've already reduced it from a fourth to a third degree. So I'm going to try -1 again. Maybe I'll get lucky. 1 drops down. Times -1 is -1. -6 and -1 is -7. Times -1 is positive 7. It's not going in my direction here because that is 19. Gives me -19, which is not 0. So I'm done with my 1s, right? Let's erase this because it didn't work and move on to 2. And really, again, all I have to do is find that next 1. Because if I find a second 0, I'm at a second degree polynomial and I can bag this synthetic division and just factor. So let's go to 2. Positive 2 here, right, means x equals -2 would be a 0. 1 drops down. 2 times 1 is 2. -6 and 2 gives me -4. Times 2 is a -8. -8 and 12, that's a 4. 4 times 2 is 8. There we go. That's a 0. 2 is a 0, right? Or sorry, excuse me, x plus 2 is a factor, which means that x equals -2 is a 0. Okay. And I'm going to stop here because this polynomial here becomes x squared minus 4x plus 4. I know it's squared because I started with fourth and I removed two of them, so I'm down to 2. So this first term is my x squared, and then I just reduce the power for each step. So all I have to do then is factor x squared minus 4x plus 2, but I know, or should know, that this is x minus 2 times x minus 2. There's my other two zeros, a 2 and a 2 again, right? And so I have that, I have 1, 2, negative 2 that is, and then 2 twice, right? So there's 3 unique zeros, but since this 2 is duplicated, that's your fourth zero. Okay? And that's my real zeros. Alright, hopefully that's helpful, and thank you, and I'll see you for the next one.